Alright guys, welcome to this page of the notes, and what we're going to do is we'll just continue with a couple more example problems of solving exponential inequalities. So let's just jump right into it. Again, if you're working ahead, please feel free to do so. If you feel comfortable with these, come on back and check your answers once you get done. What I've got is something that actually looks a little bit different. We've not seen this before. I have this whole thing in inequality, but it's greater than a fraction. Don't let that freak you out. We'll show you how it works. It's not that big a deal. First thing I need to do though is I do need to get my bases to be the same. I have a 2 on this side, and I've got a 32 in the denominator on that side. But if you think about it for a second, you'll quickly recognize, oh, hang on a second, I can rewrite 32 as 2 to the 5th power. So that's exactly what we're going to do. 2 to the x plus 2 is greater than, careful, it's 1 over, right? Because the 32 is in the bottom. 1 over 2 to the 5th power, because 2 to the 5th is 32. So I haven't done anything. All I've done is just rewritten the problem I was originally given, but I've done it so that now my bases are the same. However, I have one other problem. My base is currently in the denominator, and that's not really going to work out. I need to get that 2 to the 5th into the numerator. Well, we have a really nice property of exponents that allows us to do that. Hopefully you guys will remember this property of exponents. If you have 1 over b to the x, it'll be equal to b to the negative x. In order to bring that base out of the denominator, all you have to do is change the sign of the power. That's exactly what we'll do here. I have 2 to the 5th. To bring it to the top, I'll do 2 to the negative 5th. And there we go. Now it looks just like all of the other exponential equation problems we've done. My bases are the same. I've got my exponents, so I'll just simply set up my inequality with the exponents. X plus 2 is greater than a negative 5. Subtract the 2 to the other side, and x is greater than a negative 7. I didn't multiply or divide by a negative number, so I don't flip the inequality. I just leave it like that. And this inequality will be true as long as x is a number bigger than negative 7. Let's go ahead and try another one of these. I got one more for you here with the fraction in the where 256 is in the denominator. It's an inequality with a rational number, a fraction in it. And again, I don't think it would take you too long to figure out that I can rewrite 256 as a 4 raised to the 4th power. Greater than 1 over 4 to the 4th. Again, all I've done is rewritten the 256 as a 4 to the 4th. The bases are the same, but I still have the problem. The base is in the denominator over there on the right-hand side. So we'll bring it to the top using the same property we used in the last one. Just make the exponent negative, and that guy will come up to the numerator. All right. Well, now I've got the same basis, so we'll go ahead and set our exponents up. 3p minus 1 is greater than negative 4. And we'll solve for p. I'll add 1 to the other side. 3p is greater than a negative 3. Solve for p by dividing both sides by 3. p is greater than a negative 1. I didn't multiply or divide by a negative, so I don't have to worry about flipping the inequality, and I wind up with p is greater than negative 1. Again, what that's saying is as long as you choose a value of p that's greater than a negative 1, you plug that into this inequality and it will hold true. I got one last one for you guys to do here. Let's go ahead and take a look at this one. Again, just a little bit more practice because I do have an inequality with a fraction in it. However, 243, think about it for a second, maybe play around on your calculator a little bit, and you'll quickly recognize 243 is a 3 to the 5th power. Once again, I now have the same base, but my problem is that that 3 to the 5th is in the denominator, and that's no bueno, but we've already looked at how you fix that. Just change the sign of the power, and it'll bring it up to the top, bring it into the numerator, thanks to our properties of exponents. There we go, 3 to the negative 5th. My bases are the same, and so we'll set up our exponents. 2x minus 1 greater than or equal to a negative 5. Add the 1 to the other side. Divide by 2, and x needs to be greater than or equal to a negative 2. And again, all this is saying is as long as you pick a value of x greater than or equal to a negative 2, when you plug it into the inequality, it will give you a true statement. So x needs to be greater than or equal to negative 2. All right, guys, that takes care of everything here from Chapter 7, Section 2, where we both solve exponential equations by getting the bases the same and setting the exponents equal to each other, or solve exponential inequalities by doing the exact same thing. We need to get the bases to be the same. That way I can set up the inequality with the exponents. We also took a look at the compounding interest problem, which you guys are going to see quite a bit, since exponential functions play such a large role in modeling natural phenomenon, and we have an opportunity to do a number of real-life situations, a lot of word problems in this chapter. We're going to do it. So just be ready to see that compounding interest formula problem either on a homework. I'll definitely quiz you on it and put it on the test as well if you're taking this class with me. Anyway, I hope you enjoyed this set of videos. I had a lot of fun solving exponential equations with you guys. I'll see you next time.